Hello there guys, welcome back to another epic inexorable maths video. We've got an interesting video today. So what I'm doing is I'm going to integrate sine x times cos x in 4 different ways. Okay, so I'm going to show you 4 ways of doing this question. I'm doing this for 2 reasons. The first reason is I want to show you how important it is for a plus c. Because when we do these different methods, we're actually going to get some different answers. Okay, so depending on the method that we use to integrate this, we will literally get different answers, okay? Now you might say, whoa, how is that possible? As long as they're all correct, how are you gonna have different answers to your integral based on the method? That sounds really weird. Don't worry, it's all gonna be revealed later on in the video, okay? The key is that the answers are going to only differ by a constant on the end, adding or taking away some constant. So the plus c will be a different number for each question, okay? Or for each method of doing the integral. That's the key. That's why I want to show you how important it is to do a plus c when you integrate. And the second reason that I'm doing this video is just to show you that there are lots of ways to answer questions in maths, particularly with something like integration. There's lots of ways to answer a question. There's not just a right or wrong. Like, you know, a lot of people in maths, they think, oh, you know, this is right, this is wrong, but it's not like that a lot of the time. There's lots of ways to do it. So I just want to show you guys how sometimes maths can be kind of a bit creative. You can kind of think about how you want to do the question. There's not just a, this is the way, this isn't the way. So let's go straight into the first method for doing this integral. I'm going to do this integral to begin with using a trigonometric identity. I'm going to use the double angle formula for sine. So I know that sine of 2x is actually identical to 2 cos x times sine x. This is just an identity. This is the double angle formula. Okay? So that means that I can rewrite this integral, okay, just by using that. If you imagine halving both sides, you'd have sine x times cos x on the right hand side. This is the same as the integral of a half sine 2x. Okay, we've not integrated it yet. It's the same as that. And then when we actually do the integration, we're going to end up with minus a quarter cos 2x. Okay, so careful of the negative signs. And then of course we're going to have a plus c. Careful of the negative signs, guys, because when you differentiate cos, it becomes minus sine. So we need a minus here in order to cancel out with the minus that comes from differentiating cos. And there's a quarter there because when you differentiate cos 2x, the 2 is going to come down via the chain rule, and 2 times a quarter is a half, which is what we have there. So this is our first answer, minus a quarter cos 2x plus c. So what I'm going to do is on the right-hand side, I'm going to write down each of our answers as we go. So one of the answers that we have is minus a quarter cos 2x plus c. Okay, so I'm going to leave that there and we're going to come back to it. That's our first method of integrating sine x times cos x. Okay. The second method that we'll use is by using the chain rule. Okay. So let's think about this for a second. You already know that sine differentiates to cos. So what we have is, you could potentially think of this as something that's been differentiated already and we're just going backwards. So let me just propose something to you guys and you can think about whether or not you agree. If I was to differentiate sine squared, so sine x squared. If I was to differentiate this, what would happen? Well, the 2 would come down. The inside of the brackets is going to differentiate to cos, which is going to come out. And then I would need to take 1 off the power, so it would become sine, just sine on its own. But guys, look at this. This is just twice the integral. So that means that via the reverse chain rule, this integral should be equal to half of sine squared x. So 1/2 sine x all squared, 1/2 sine squared x. And again, we need a plus c. So let's just, again, if you're a bit lost there, just think about it. If you differentiate sine squared, the 2 comes down, cancels out with the 1/2, so there's nothing there. The derivative of sine is cosine, so a cos pops out. And then take 1 off the power of sine, sine. So you have overall sine times cos, which is what we have here. So with our second method of integration, and this is also correct, it's just a different thing, we have 1/2 sine squared x plus c. Okay, that's our second method. All right, the third method is going to be quite similar to this. We're just going to do it the other way around. So instead of saying, oh, well, you know, when you differentiate sine, you get cos. Well, when you differentiate cos, you kind of get sine. You get minus sine, but you get something similar to it. So let's do the exact same thing here. We're going to differentiate cos squared. Cos x squared, put some extra brackets around that so you can see it. Well, guys, what's going to happen here? Well, the 2 is going to come down. This is the chain rule. The 2 is going to come down. The derivative of cos is minus sine, so we need to times this by minus sine. And then we're going to take 1 off of the power of cos. Okay, so what do we have here? We have minus 2 lots of sine x times cos x. Okay, so with the exact same logic as before, the integral here must be equal to minus 1/2 times cos squared. And the reason for that, you'll see in a second, minus 1/2 cos squared x, don't forget plus c. And again, just so you can make sure that you agree with this in your head, this is the reverse chain rule. Differentiate this, the 2 comes down, cancels out with the 1/2, so we have minus, there's still a minus there, but it's just minus 1. Then you differentiate cos, which becomes minus sine, so the minus and this minus cancel, so you're positive, and you have a sign there, and then you take 1 off the power of cos, so you have 1 lot of cos times sine, or 1 lot of sine times cos, which is this. So this is also a valid answer. So our third answer is minus 1/2 cos squared x plus c. So all 3 of these functions, they're all different functions. All of them are different. There's no, just to be very clear, these aren't the same thing, but with some sort of trigonometric identity, you know, activity going on. They are all different functions. They are different. You cannot use an identity to get to the other one. They're all different. And then the last method we're going to use, I just realized there was a 1 there. I was going to label them 1 to 4, but I wasn't counting, so that's fine. Anyway, this is the 4th one. What do you guys think the 4th method will be? Well, we can use integration by parts because it's a product of 2 functions. Okay, let's use integration by parts. So, it doesn't matter which one is u and which one is dv dx because they have the same order of priority because they're both trigonometric functions. So you can choose which way around you do it. I'll let u equal sine x because I think that might be easier. And I'll let dv dx be cos x. Okay, so what does that mean that du dx is? Well, du dx is going to be cos x. And what will v be? Well, what's the integral of cos x? Well, cos x integrates to sine x. Okay. So now we have this, and now we can just use the formula for integration by parts, which I've not written it down, but if you remember it, then we are very happy. We now have that the integral of sine x times cos x. And you're about to see something very cool, guys, if you've not seen this before. This is a cool thing you can do with integration by parts. First of all, is u times v, so sine times sine, that's sine squared x, okay, minus the integral of du dx times v, which is sine x times cos x, okay, the integral of sine x times cos x. Now you might say, oh no, we've made a mistake because You just got the same integral on the right hand side. That's not very good. But guys, watch this. If you add the integral of sine x times cos x to both sides, right, then you have 2 times the integral of sine x times cos x with respect to x is just sine squared x. Okay, we've added to both sides. And then you can just divide both sides by 2. So dividing both sides by 2, we have that the integral of sine x times cos x with respect to x, just dividing both sides by 2, is going to be 1/2 sine squared x. And I'll put the plus c right there. You could put the plus c a couple of steps higher, but it's fine. Okay, so we have 1/2 sine squared x plus c. Now we already have this one, 1/2 sine squared x plus c. That's the second one up here, but still, it's quite weird because as you can see, some of them are the same and some of them are different, right? But we do have 4 answers and 3 of them are not equal. So we have sine squared and sine squared, fine, but the first 3 are not equal to each other in the slightest. So what I'm going to now do is on the screen you will see on Desmos the graphs of all 3 of the first functions, minus 1/4 cos 2x, 1/2 sine squared x, and minus 1/2 cos squared x. The fourth one is just the same, it's just 1/2 sine squared x, so I'm not going to show that. So you're looking at the first 3. Now notice that they are all the exact same shape, but they are just, you know, kind of on top of each other. So one is higher than the other, which is higher than the other. So if you were to choose appropriate values for c, you could make them all be equal to each other. You would just need to choose different values for plus c, okay? So one of them, c might be, it might have to be 1 more than another one, or it might have to be 2 more than another one, or whatever the number is. That's fine. This is the point that I'm making with this video. The reason why it's so important to do a plus c when you integrate something is because if you don't write plus c, then you are wrong. Because if I hadn't written plus c on these 4 answers, then they wouldn't be equal to each other ever, at any point, regardless of any value of c. And by the way, these values of c are different to each other. So all I have to do is choose the correct values of c with respect to each other in order for them to be equal, because I've given myself that freedom of saying, aha, but I have a plus c, I can choose what c is. I can make c be such that these are equal. But if there is no plus c there, they are never equal. So all 3 answers are different to each other, which is impossible because you've correctly integrated the same thing, yes, in 3 different ways, but you've correctly integrated the same thing, so it makes no sense that they're not equal to each other. The plus c allows the freedom for them to be equal to each other. That's the idea. So if you don't put a plus c on an indefinite integral, you are wrong. It's not being pedantic. It's not saying, oh, well, you know, we don't really need the plus c, but, you know, we're going to take marks off you if you don't write it. If you don't do a plus c, you are incorrect. And that's the important thing. And this is a prime example, I hope, of why exactly that is the case. As always, guys, thank you so much for watching. I hope you found this video helpful and insightful. Share with all your friends and family, and I'll see you in the next video. Cheers.